there are different classification of the soilless production systems, and as we'll see later on, the classification are dependent on the rooting environment. Either it will be substrate, artificial or organic media, it might be water or nutrient solution more exactly, and can be air. And then within each of these main categories there are subcategories depending on some specific technicalities. However, the main classification of the protected cultivation system is the one who split them in the open soilless production system and closed soilless production systems. Obviously, the open soilless production systems use the nutrient solution only once. It goes through the substrate or pass through the root system of the plants and then is getting out of the system. It is into the environment, and because of that, it is easily understandable that the impacts, the negative impacts on the environment might be high. It will be a significant amount of nutrients which are lost and when going into the environment. Therefore, there's been a lot of pressure to reduce these negative effects on the environment, which lead to the development of the closed soilless production systems. In the closed soilless production system, the drain nutrient solution is recovered, replenished, and recycled again to the plant. It is clear that it requires more precise and frequent control of the nutrient solution. It requires much more technical know-how. It is more sensitive to operational mistakes, in particular during the springtime, due to the possible increase of nutrient concentration in the solution, because this period of the year the temperatures of the air are gradually increased and due to the increase of the solar radiation. Therefore, in the closed soilless production systems, the return nutrient solution has to be treated to restore its original nutrient element composition and to remove any foreign substances. As we will talk later on in next lesson, we need to know that during the use of the nutrient solution, the plants are absorbing selectively either water or nutrient elements, and they might also be selective to specific nutrient elements, and thus they change the composition, they change the concentration of specific ions in the nutrient solution. Thus, before we reuse it, we have to restore somehow the original composition of the nutrient solutions. But furthermore, during the use of the nutrient solution, the plants are able to change its pH. It might become more acid or more basic, and thus by this way it can affect later on the uptake rate of different nutrient elements. So because of this reason, again, the returned nutrient solution has to be treated to restore its original nutrient composition. And next, in the closed soilless production system, there is a high risk of spreading the root-borne diseases. Maybe there are plants which are affected by specific diseases, and by recirculating the nutrient solution, we may spread it over the entire greenhouse. And because of that, it is a necessity that before the before reusing the nutrient solution, we must sterilize it in order to get it free of several diseases. There are different methods of sterilization. Can be heat treatments, it can be ultraviolet light sterilization, can be chemical oxidation, or it can simply go slowly through sand filters. Okay, each of these techniques have its own specific requirements, but no matter which one we have choose, it must be sure that we have a recycled nutrient solution free of any disease. Otherwise, the negative effects on the plant productivity will be very high. This is a schematic representations of the open and closed soilless production systems. And as you can see from this scheme here, there is water collected from the rain, and there is water pumped from the underground, which are mixed together, and obviously we use the rainwater to improve the quality of the water we use for preparing the nutrient solution. And we have already explained how important is the quality of the water for crop growing in general, and especially in soilless production systems. And then the water is filtered and going through the main pipe. It's enriched with different nutrient elements by specific pumps, which are sucking saturated nutrient solution for several tanks. In this specific case, there are 3 tanks, A, B, and C. The last one is with acids, and A and B we can put different salts. It's important that you keep separated the calcium salts from phosphate salts, otherwise we will have a very intensive chemical reactions, which will end up with specific substances which are not soluble into the water. We'll talk about this later on. And of course, we need to use acids in order to fit the pH of the nutrient solution at the appropriate level. It must be at the level of 5.5 to 6.5. And then the nutrient solution later on is going again through filters. Keep in mind that we up to this point we have water, simply water, and from this point and on we have nutrient solution. It is filtered again, the nutrient solution is filtered again, its EC, electrical conductivity, and pH are measured, and then it is been delivered to the plants, to the crops. The drained nutrient solution is collected in a catchment tank. Its pH and EC is measured again. And now at this point starts the difference between the open soilless production system and closed production soilless production systems. In the open system, you can simply from the recatchment tank leave the nutrient solution to get out of the system to go to the environment. Otherwise, in the closed soilless production system, it is recycled, it is disinfected, it is restored, when it's needed for its original composition, and then it been recirculated in the system. So this is a schematical view of both systems, and these are the differences between these two systems. Of course, that by having open or closed soilless production systems, we might have some differences regarding the yield, expected harvest yield, and but much more on water use efficiency and the nutrient use efficiency. From this table here, you can see that there are non-significant differences in the harvested yield between the open system and closed system. But we should say that having a closed system, we are under a certain pressure of reducing yield, and it might happen sometimes if the nutrient solution, recirculated nutrient solution, was not managed properly. But there are a lot of benefits regarding the water use and nutrient use efficiency, as you can see from the table. In case of the open system, it is about 8,600 cubic meters per hectare, and it's only 6,800 cubic meters per hectare in closed system. So there is a saving of water of about 21%, and there is from the total of water used in open systems, there is about 1,700 cubic meters just when going out into the environment as a drained water, as a drained solution, while there is zero cubic meter lost in the closed system. So we have a significant saving of water, about 2,000 cubic meters per hectare, due to the use of the closed soilless systems. And the same with the use efficiency of nutrients, of nitrogen, phosphorus, potassium. You can see that there are savings of 35% on the use of, regarding the use of nitrogen, out of 1,600 kilograms per hectare which are being used, nitrogen which are being used in open systems, only 1,000 kilograms per hectare were being used in closed systems. And there is of course no leaching at all of the in the environment in the closed system for nitrogen, and there is a significantly higher crop uptake by the crops, by the plants, by 22% higher nitrogen uptake. And similarly, we can see that also in the case of phosphorus and potassium, the use of closed system reduces the total amount of nutrients, phosphorus or potassium used, and it makes zero the losses to the environment and increases the crop uptake rate of each of these elements. And this is why the closed systems are largely used in commercial production. But I want to remind you that on the other side, they are asking for much more skills, much more know-how, and very experienced people to properly conduct systems in order to avoid any human mistake which might be very costly for the producer.